Welcome to this video lecture. Myself Atul Kumar, working as a assistant professor in Department of Computer Science, Rajiv Gandhi Memorial, Government College, Joginder Nagar. In this video lecture, I will discuss about extended ER features, that is also called enhanced ER model. So, with the rapid increase in the developments of new database applications like engineering, design and manufacturing, telecommunication, image and graphics, multimedia, data mining, data warehousing, geographic information system, that is a GIS, we need new semantic data modeling concept. So enhanced ER model is a result of these new kind of applications, database applications. So in case of extended ER features or enhanced ER model, we have three concepts. One is generalization, other is specialization and aggregation. So what is generalization? Generalization is basically a bottom up approach, and here the two levels, that is lower levels entities, combine to form a higher level entity. As shown in the diagram, we have a lower level entities, a saving, and other is a current. So these are a lower level entities. When we combine these two entities and it become a higher level entity, and that is a account. The account may be saving account or a current account. So this kind of approach is called as bottom up approach, and we represent generalization with the help of a diamond shape, and inside this written it as is a. So generalization is basically a bottom up approach in which two lower level entities combines to form a higher level entity, and in generalization the higher level entity can also combine with other lower level entity to make further higher level entity. This means if we want to combine this higher level entity with other entity to become more higher level entity, then in that case generalization is also possible. So next, what are the different properties of generalization? So generalization exists only when the distinct low level entity set have common attributes and have same relationship types. This means if they have in this case or in this example, we have two accounts, saving and current. These are lower level entities and they must share the common attributes, as both saving and current entity is a account, is a form of account. So they share the some common attributes like account number, uh, or account bank type. So these are the common entities, attributes that are shared by these lower level entities. Only then we will go for generalization. So it exists only when the lower level entities set have common attributes and have the same relationship types. So the relationship is also same in this case, as saving and current have the same relationship. Next important property is it is a bottom up approach, as shown in the diagram. We start from the bottom and go to the upward side. Next important property is the double E diagram, that is a entity enhanced entity relationship diagram represents the generalization in the same way as of specialization, that I will discuss in the later slide, and with the help of a triangular component labeled as is a. So to represent a generalization we use a diamond shape or a triangular component, and inside this we will write is a. So if we write is a inside this kind of shape, then it is the symbol of generalization. Next we have a specialization. So the specialization is basically the opposite of generalization. So it is basically a top down approach in which the higher level entity can be splitted or broken down into a lower level entity. So this one is the diagram or ER diagram to show how specialization is represented. So student is a higher level entity, and if we broke down this student into lower level entities, that is the first entity is X student and other is CURR student, that is a current student. So this kind of uh, approach is called as specialization. And also in this case we have a diamond shape, and inside a diamond shape we have a representation, and this is the representation of the specialization. Also it follows top down approach. So different properties of specialization include: it exists only when there exist specific or unique attributes of the subclass entity set. Like in this diagram we have a student entity, and we divide this student entity into X student and current student if they have some unique attribute. So X student have some unique attribute. We have uh, X year and as a unique attribute for the sake of example, and we here we have a current year. So this one is a unique attribute that that is only related to this kind of entity. So current year is related to this current student, and X year is related to this X student. So if these kind of attributes are available, only then we can go for specialization, and we divide or broke the entity into two or more lower level entities. So next important property is it follows top down process. So the next important property is in entity enhanced relationship diagram, specialization is represented by a triangular component labeled by is a, as shown in the diagram before. So the is a relationship is also known as superclass subclass relationship. Here the top class or higher level entity is the superclass. It is called as superclass super class, and the lower level entities, that is current and X student, they are the subclasses of this superclass student. So in case of bottom up design, we generalization, we use bottom up approach, combine the number of entities into a that share the same features into a high level entity. So specialization and generalizations are simply the opposite of each other, that is inversions of each other. They are represented in the ER diagram in the same way, and the terms specializations and generalizations are used interchangeably. So if you see this diagram and the previous diagram, there is no difference in case of diagram whether it is a generalization or whether it is a specialization. So the only difference is whether you follow top down approach or bottom up approach. If you follow bottom up approach, then the process is generalization. If you follow top down approach, then the process is specialization. So we can have multiple specializations of an entity set based on different features. For example, permanent employee versus temporary employee in addition to instructor and secretary entity. So we can have more than one specialization. For example, this one is a employee, and employee is we have a entity called employee, and we have is a. So we have multiple kind of specializations. One specialization is uh, permanent employee. Other specialization is temporary employee. Temporary temporary employee. Other kind of entity is instructor, and other we have a secretary. So we have multiple kind of specializations available. Next we have each particular employee would be the member of one of the permanent employee or temporary employee, or it may be also the member of instructor and the secretary. Next important feature of enhanced entity relationship model is aggregation. So it is a process of combining entity sets and their relationships. So if we combine entity set and the relationship, then it is called as aggregation. So we treat the higher level entity set is treated as a single entity. Like in this diagram we have this is a single entity. Here we have entities university and applicant, and there the relationship between university and applicant is interview, as university is taking the interview of the applicant. Also we can't make connection with this interview relationship with other relationship. Also university after conducting the interview, it will give you results and provide the job offer to the applicant that passed in the interview. So there we can't just show or make a connection between a relationship with the relationship. So to make this, we just combine this entity relationship between university and applicant into a higher level entity, and it is treated as a single entity, and it is called as aggregation. And the symbol here to represent aggregation is like a small diamond as shown here. This is the symbol of aggregation. So aggregation is done to combine the entities of university and applicant and the relationship between them. So they are represented by a rectangle enclosing all the three. So thanks for watching this video lecture.